In understanding trigonometry, like I previously mentioned, that we are going to be dealing with trigonometry this week. So what we are going to be doing is that we are going to start from the scratch so you can understand what trigonometry is all about, what we call trigonometric ratio. So when you look at this, you can see that this is a triangle and that is a right angled triangle. So what that means is that for you to solve problems in trigonometric ratio, one condition is that the triangle must be a right angled triangle. So you have to stick that to your mind. And then when you look at this, then we have three sides of a triangle. So we have what we call the opposite side, the adjacent side, and then the hypotenuse side. How do we recognize these things? How do we know which is opposite, which is hypotenuse, which is adjacent side? So very simple. Now look at the angle here. I've given an angle here as theta, and theta simply means the angle. So, and it is opposite to this side. So because it is opposite this side, it automatically becomes what? The opposite. And then this is the right angled side. This is the right angle. The right angle automatically is opposite to the hypotenuse side. And then the other side, now the adjacent. So that is very simple. Then when you look at this one, that's an abbreviated form of adjacent, hypotenuse, and opposite. You can see it here. This is the opposite. This is the hypotenuse because it is what? Facing the hypotenuse side, and then this is adjacent side. So how do we now name these ones? We name them because it is from what we have said, you can see that this is the angle, that is the angle theta, and then it is facing the side, so this is the opposite. And then where is the hypotenuse? Look at the hypotenuse. Now look at where it is what? Facing. This is the hypotenuse. And then here becomes what? The adjacent. So that is how to note that. Now let us look at this one. This is the the angle. This is the angle theta. Where is it facing? It is facing here. So this is opposite. And then where is the right angle? This is right angle. Here is the hypotenuse side. And then where is now the adjacent? So this is the adjacent. Okay. The same thing applies to here. So look at this. This is the opposite. This is the opposite. Then this is the hypotenuse. This is the hypotenuse. And then here becomes the what? The adjacent. So it is very simple. It's just to take a look at the what? The triangle, and then see where the angle is facing, where the right angle is facing, and that determines what? The going deeper into trigonometry. So we need to analyze the trigonometric ratios. So they are very important. So we need to understand this trigonometric ratio so that solving problems won't be an issue. Already we have recognized the side that are opposite, the side that are hypotenuse, and then adjacent by looking at the triangle being a right angled triangle. So we can analyze that based on the angle that the side that the theta is facing is the what? The opposite. The side that the right angle is facing is the hypotenuse, and then the other one is the adjacent side. So here we will look further into the trigonometric ratio. So we are going to look at so, and then ka, and then tua here, and a formula, so as a guide. So we are going to use it as a kind of guide to solving problems in trigonometric ratio. So what is SOA? SOA, you can see, is sine. S stand for sine, O stand for opposite, and H stand for hypotenuse. So that means that sine theta, sine of theta is equal to opposite of hypotenuse. Cos theta is equal to adjacent of hypotenuse, and then tan theta is equal to opposite of adjacent. These are the ratios. So we already know the what? The sides that are opposite, the side that are adjacent, and of course the hypotenuse side. So let us look at this triangle. Looking at this triangle, then what do we have to ask ourselves? We ask ourselves which side is the theta facing, and then which side is the what? The right angle facing, and that determines the ratio we are going to be using. So take for instance this triangle. We saw that A is given, and A, the theta is facing it, that is opposite, and then B was given, and that is hypotenuse because the right angle is facing it. So that means I am going to do sine theta because I have the opposite, and then I have what? Hypotenuse. So that is how I choose sine. Now looking at this one, when I look at this one, I look at the theta, and then theta is not facing anything. So what I am having here is that I have x here, so which is this, and then this is the hypotenuse. So nothing was given in the opposite, and then something was given in the adjacent and then in hypotenuse. So that means the ratio I am going to be taking is cos theta, because I have adjacent here and I have hypotenuse side. So that's how to determine which one is going to be what carried along. And then looking at the third one, you can see here, look at my angle is facing P, and then hypotenuse was not given. So, and then adjacent was given. So then when I look at the trigonometric ratio, I can see opposite and then I can see adjacent. And the opposite of adjacent is tan. And that's how we take these things. That's how we pick these ratios. So you have to understand that very well.